Welcome students. This is our CMP lecture series. From last 4 lecture we are discussing about the semiconductor. The in 1911 the semiconductor firstly introduced by the Jones H.K. Owns, that name of the scientist. And after that the number of researcher getting research on a different phenomenon regarding with the superconductivity. Now in previous lecture we are discussed about the Meissner effect, and later one, that is critical field or the critical temperature, as well as the persistent current. So further we move towards the another one topic. It is a very important topic related with the examination. This topic is important with the theoretical questions if the pandemic is over. Otherwise, it is also important for the MCQ pattern examinations. So let us start the new topic. That name is the London theory. The London theory, in that the word London, it is not show the name of a city. It is shows the name of the scientist, that is the London brother. Look at that picture. The first one, the name of the scientist, that is Fritz London, and second one, that is the Heinz London. These brother are introduced the London theory in 1935. It discovers the magnetic field are expelled from the superconductor. That means it is a very essential topic regarding with the magnetic field. The firstly I want to say here, the Maxwell equations we know very well, but when the superconductivity is introduced, at that time the Maxwell equations are not be explained these formulas, or it is not to be clear, getting clear idea from the Maxwell equations. That's why these two brothers, that is Fritz and Heinz brothers, or the called as the London brother, are just changes about our Maxwell equations, and this explanation is comes from the Meissner effect. This explanation is comes from the Meissner's effects. Now let us start. We know very well about the fluid model. We know very well about the fluid model. In that model, the superconductor is supposed to be composed of two distinct types. That means I would just explain another word is here. The London brothers are introduced the two electrons. One is called as the normal electrons and another one is called as the super electrons. The normal electrons, it behaves like the normal, that is called as the usual manner. But the super electrons behaves like a different as compare a usual manner. In that normal electrons getting a scattering experience. Normal electrons has the scattering experience, but the super electrons are not a scattering experience. These are the major difference between the normal electrons and super electrons. Please note the students this one. The normal electrons does not experience normal electrons experience the scattering, but the super electrons are not experience the scattering. It is important for the MCQ patterns. Okay, now next, whenever the material, that is a superconducting material, which we have considered or which have the suppose the temperature at the critical level, that means the critical temperature of that superconducting material, the electrons are normal above that, above the critical temperature in that superconducting material, in that superconducting material, the above the critical temperature, the electrons behaves like the normal. But when our superconducting material getting into the below of that critical temperature, below that the critical temperature, the electrons are turned in a super electrons. The electrons turn into the super electrons. That means they experience the no scattering was there, no scattering was there. And until this phenomenon is same until at our temperature is equal to the 0 Kelvin, at temperature at 0 Kelvin. But whenever we are moves about the critical temperature, whenever we are going to move above the critical temperature, the electrons turns back into a normal. This idea by the London brothers, and they put forwarded, and he just consider that the total sum of the normal electrons and super electrons, they just assume that, or he just experienced that the total sum of normal electrons as well as the super electrons is equal to the conduction electron density, is equal to the conduction electron density. That means so now let us see. Okay, we are getting clear idea with the help of this equation. Now suppose consider this n, it is the density of conduction, this n is the density of conduction, and this ns, it is a density of the, just a mistake, one is the nn, this first one is nn. Okay, now this nn is the density of normal electron, and this ns is the density of the super electrons, and this equation shows you the conduction density is equal to the normal electron density and sum of the normal electron density and the super electron density. Now further, suppose the flow of the normal current and super current. Now suppose that the flow of normal current and super current are parallel. These two are parallel. Now what happen in that situation? The super current flow with no resistance. What happens at this situation? The super current which is possessed by the super electron, it flow with the no resistance, and the normal current cannot flow without a resistance. These are the important sentence. Super current flow with no resistance and normal current are flow with the resistance. That means it is normal electrons experience the resistance and super current has not experienced the resistance. Okay, now and it is completely entire current induced by a very small transitory electric field. So that means it is not a bigger providing a large number of electric field, or that the current flowing through that the circuit. Okay, now next, the normal electrons will remain quite inert, and therefore ignored in a following discussions. Now getting the first, it is a one important, we are going to solve the first equation of London's first equations. Okay, now move on these important point, that is London first equations. I am not putting the heading because I want to just complete theoretical portions in that first equation and second equations in a continue lectures. That's why I am not putting the any headline was here. Okay guys, so let us suppose that the E is a electric field which arises in a superconductor. Let us consider that is capital E. It is an electric field. It is an electric field which arises in a superconductor with the moving of freely accelerated super electrons. That means the super electrons was there. Okay, now let us V means velocity, and what is the S? Yes, that is suffix S. It nothing but the super electrons. This S is nothing but the super electrons. That means it is an average velocity of free moving super electrons. Vs is the average velocity of free super electrons. Now m, what is the m? M is the mass of that electrons. E it is nothing but the charge. E is the charge. The charge is present on that super electron. Now let us the equation with the help of motion equations. The equation is nothing but the mdvs by dt. mdvs by dt is equal to minus of E into capital E. Minus of E into capital E. Just I am explaining again. What is the m? Mass of that electrons. What is the Vs? That is the average velocity. What is the E? Is the charge on that super electrons. And what is the capital E? It is a electric field. Okay. Now we just find out the current density of super electrons. The Js is equal to minus of E Vs Ns. What is the Js? That is the current density. What is the E? Charge on that super electrons. What is the Vs? That is a velocity, average velocity of that super electrons. What is the Ns? Ns is the density of super electrons. Now just putting the derivative, that is the djs by dt is equal to minus of ens into dvs by dt, just getting derivative of both sides. Okay guys, so now these equation number 2, this one equations. Now from these equations, that is nothing but the dvs by dt was here, dvs by dt is here. This m getting this sides, that is minus ee by m. That means this dvs just replaced by these equations. Okay, now getting these equations. djs by dt is equal to minus of ens in a bracket minus ee divided by m. This dvs is replaced by this one. Okay, now put the equation number, the equation number was 5 is here. Just a moment guys. Okay, now and these equations, which equations? These equations is called as the London equation first. This is called as the equation first. Okay, now move with the second one equations. Now this equation shows that it is possible to have the steady state current in absence of an electric field. It is the simple possibly to have the steady state current in absence of an electric field, because in the equations, these equations are E is equal to 0. For E is equal to 0, if we consider that is this E is equal to 0, that is E is equal to 0, 0 multiply anything, that is 0, 0 multiply anything, that is 0. That means djs by dt is 0, and if these are the 0, that means j is a finite or a constant, Now the move with the normal situations, it is completely related with the superconducting state, super electron state. Now we are moving with the normal ones. Now corresponding expression for a normal density is Jn is equal to rho into E. Jn is equal to rho into E. Whatever that equations, just forget. Equations, these are continuously. I think these are the equation number 6. Okay. So in that equations, it shows the no current is possible in the absence of electric field. It shows that the no current is possible in the absence of electric field. But here the current in absence of electric field, steady state current will passing through that, and here there is no current. There is no current is possible in the absence of an electric field. That means their behavior is like a normal state material behavior. Okay, now conclusion. Now we are moving to conclusion. So that conclusion is the simply, that is the E is equal to 0. E is equal to 0. It leads the another important result. That's E is equal to 0. They leads an important result. We know the one of the equations, that is the del cross E is equal to minus dB by dt. We know these equations, Maxwell's. Which equations? These del cross E is equal to minus dB by dt. Minus dB by dt. What happens when the putting the value of E is equal to 0? What is the value? That is E is equal to 0. That means dB by dt is 0. dB by dt is equal to 0 at B is a constant. Now in that equations, the steady state, that means the B is a constant in the steady state when the superconductor, irrespective of its temperature, the B is a constant inside a superconductor irrespective of its temperature. Now from such a phenomenon, the London brothers suggested the some modification. London brothers suggested the some modifications from above formulas. Now the formula is for this formula, that is djs by dt. djs by dt is equal to E square NSE, by m. Okay, from these equations we just taking curl of the equation 4 and put the value of E in equation 6. Put the value of E in equation 6. That equation 6, that means this one equations. Okay guys, the taking the equation numbers are moved from above and below. It's something were wrong. So just taking these the curl. It's not important the which type of these equations are given. The equation number was given. Equations, I will show the equations. Okay, taking the curl, when we are going to curl of these equations, after that the put the value of E, put the value of E. What is the value of E? That is del cross E minus dB by dt. That means the value was dB by dt is here. Now after that we are going to taking integrate of this equation. We are taking the integrations of this equation with respect to time, with respect to time. And whenever we are going to taking integrate of this equation with respect to time, that means these equations is like the del cross js, del cross js is equal to minus ns e square m into b, and this equations is called as the second London equation, equations. Okay guys, this is all about the equations of London first and the second equations. So I hope we are getting easily idea about the London theory, introductory portions of London theory, and these two equations of London theory, that is the first equations and the second equations. I hope you are getting clear idea from the London theory. If you have the any doubt related with this theory, then please ask me. Okay, I hope you enjoy these lectures. Thank you guys.